Hey everyone, welcome to this particular course. In this section, we are going to discuss regarding the Palo Alto Firewall architecture, right? So we know that this is a very important topic, and while beginning with your Palo Alto Firewall configuration and its journey of its certification, you must know the architectural components and you must remember all those terms, right? So we will talk about what are the different components that is part of your Palo Alto Firewall architecture, right? Okay, so we will talk about the different components that fits together in this Palo Alto Firewall architecture. And now let's look into the documentations of it, where we will we can take some reference example of Palo Alto documentations and discuss this, right? So Palo Alto, as we all know, it follows something called as it is going to have this architecture name called as SP3 architecture, right? It is called a single pass parallel processing architecture, or as the name says, it is SP3 single pass parallel processing architecture, which enables high throughput, low latency network security, even while incorporating unprecedented features and technologies, right? So basically Palo Alto network, it solves the performance problems that plague today's security infrastructure with this SP3 architecture, which combines two complementary components. So these two are the main components. One is called as the single pass software and one is called as the parallel processing hardware, right? So you can say the OS, it is having this feature called as single pass operating system, and the hardware on which the OS is running, it is having this feature called as parallel processing hardware. So the overall result will give you a perfect mix of raw throughput and the transaction processing and network security that today's high performance networks would require. And as this diagram shows that, hey, it has got multiple components. So it looks like a single firewall, but inside the single firewall you are dividing this particular firewall into multiple components, right, based on its features. So the firewall will have its own independent policy engine. The firewall will have the feature that runs alongside with this policy engine called as application ID, user ID, content ID, right? It will have its own networking layer where all this routing and NAT, QoS, everything will take place. And plus, in terms of so all those elements that you see, this is the elements that is part of your operating system. And in case of your hardware, right, it has dividing its hardware into two different planes. One is called as the control plane and one is called as the data plane. So the control plane is basically keeping the management interface, right, and the data plane, it is going to contain the networking, the security, and the content, right, and the content of the device. So these are kind of multiple, you can say, processors, right, multiple processors that has been implemented into its particular hardware, right? So this documentation will help you to understand the things much more better. So let's jot down some few points, and so you can have this notes alongside with you, and you can also refer this whenever it's required. Okay, so I always prefer doing some whiteboarding and writing some good points, key points about a particular topic, and then give it you as a reference so that you can refer it, and anytime whenever you need to revise or go through it, you have these documents handy, right? So first of all, as I've told you that this Palo Alto network firewalls, it uses a single pass parallel processing architecture. So this is going to be Palo Alto firewall architecture. Let me jot down some key points here, right? First point, as I've told you, it uses SP3 architecture, which stands for single pass parallel processing. Okay, now that means it has got multiple components, right? So we'll discuss regarding those. So which is basically designed for this concept of single pass parallel processing is basically designed to uh, give the high performance. It is designed to provide low latency, right? And it is going to give you deep security inspection, right? So if you want to break down this particular into multiple pieces, so it is like that. Means instead of processing your network traffic multiple times, right, for different security functions as your traditional firewalls are doing, right? So traditional firewalls, as you know, it will go and check. So when the traffic is ingress on a traditional firewall, so before the traffic leaves that particular firewall, and there are multiple components that the firewall will check the traffic for, right? It will check the packet against specific URL filtering component. It will check the traffic against a different antivirus component, right? It will check the traffic against quality of service parameter component. Likewise, identity and access management component probably, right? It can go and check against your DLP parameter component, then your IPS component, right, your proxy component. So there are multiple engines that you can say are inside a traditional firewall, and the packet has to pass through each and every component of that particular traditional firewall before it can go ahead and take a decision of getting routed outside or not, right? So this takes tremendous amount of time. So this will take a huge amount of time for the packets for multiple packets to be processed at a given point of time, right? So that is the reason the next gen firewall like Palo Alto has got this architecture called as SP3 architecture, which makes it much more efficient, much more performance oriented, right? And it is going to apply this multiple security features at a go or at a simultaneous level. Okay, that means this is going to provide the feature called as single pass scanning, and it will give a feature called as low latency. That's the important piece, right? That means what are the advantage you get is with this single pass parallel processing architecture is single pass scanning. So basically the traffic is scanned only once for threads, applications and content filtering, right? So you can make a note out of it. So traffic is scanned only once for threads, application and content filtering, right? And it will give you the feature called as low latency. That means because all security functions are applied in single pass, that is there's a minimal delay, right? So there will be minimal delay, right, for the packets to get processed. And the number two important point is that parallel processing, right? Parallel processing. So over here, so basically it defines the firewall processing power is divided across specialized components, allowing multiple security tasks to run at same point of time, right? For example, it will have this element or component called as NPU or network processing unit. So it is part of the hardware, right? So it will have a component called as NPU or network processing unit. The function of this is to handle routing, switching and VPN function. Handle routing, switching and VPN functions, right? NPU job is that. Another component that is part of the parallel processing task is having a hardware which is called the security processing unit or SPU unit, or you can say SPU, right? So it is going to handle or perform threat detection, threat detection, antivirus scanning, and content filtering. For example, URL filtering, for example, file type blocking, etc., etc., right? And it will also have another engine called as signature matching engine. Signature matching engine. So the function of this is to detect malware, detect any sort of malware or spyware, and any sort of intrusion attempt in an efficient way, right? So, and as you've seen that in this SP3 architecture, right? So these are the benefit that you get, or these are the components that you have in the SP3 architecture, right? And there are some key functional components as well that you must remember. The key functional components. Okay, what are the key functional components you have? First thing is the control plane. So as you have seen that in this diagram, right? So you have got a specific control plane and a specific data plane, right? So you've got a specific control plane, so it is going to handle your any sort of management and any sort of configuration task. So whenever the administrator is taking the management or of this particular firewall, or it is trying to do any sort of configuration on this particular firewall, then this is the responsibility is taken care by the control plane in the hardware. Okay, so basically the job of the control plane, it is to run the management and the configuration task. So it will run the firewalls in operating system. So its task is to run the PAN OS, run the PAN operating system, right? It is going to manage the policies, user authentication, and logging, right? So it will manage logging, user authentication, and security policies that the administrator is configuring. Okay, plus it is going to use a dedicated CPU to prevent any management task from affecting performance. So it has got dedicated CPU for its management task. That means the management interface or the management plane will have a separate CPU dedicated to it. Okay, that you can see in the diagram as well. So you can see the management plane has got a separate CPU dedicated to it. Okay, so if the data plane component is kind of freezed, so that does not impact the management plane, because the administrator can go ahead and access the management interface of this firewall, although the, let us say, the physical interface or the data plane component is completely used as 100%, right? So yeah, going ahead, that means the second factor in this functional component is the data plane, which is going to work for your traffic processing. That means it is going to work for your user data, right? User data. So it is going to handle the packet forwarding and inspection. So handle packet forwarding and inspection. It is going to consist of multiple hardware engines like NPU, SPU for parallel processing. So it contains this network processing unit, security processing unit, right, for parallel processing. Okay, and it perform deep packet inspection. It perform deep packet inspection and applies security policies. Okay, that's important, right? So yeah, Norbert's, at a very conclusion level, so Palo Alto firewalls, they are very high performance security appliances that is designed for modern network environments. This SP3 architecture, it will enable deep inspection with minimal latency, making them a strong choice for enterprise and your cloud security environment, right? So yep, so it has got single pass processing or single pass software, parallel processing hardware, as I've told you. It has got dedicated control plane, dedicated data plane. So there is a dedicated CPU, dedicated RAM for its control plane function. There is dedicated CPU and RAM for its data plane function, right? And there are different types of processors, as I've told you. So one is security processing unit, network processing unit, and there is also signature matching processors, right? That is available over here, right? And you can see there is there will be one of the diagram which I kind of find quite interesting is this. Yeah, so you can see that because of the single pass parallel processing architecture, you can see that it is the Palo Alto Next Gen Firewall is empowered with single pass software which processes the packet to perform functions like networking, user ID, policy lookup, traffic classification with app ID. It can do decoding, signature matching for identifying threats and contents, which are all performed once per packet as shown in the illustration below, right? So it says that let's say a packet is entering the firewall, and what happens, right? So the packet will enter the firewall will have separate layers of inspection of this particular packet. It can do layer 2, layer 3 networking, it can do HA, config management, reporting, etc. The packet, once it's inside this firewall, it will be passing through multiple layers of user ID check, app ID check, content ID check. Then it will look into the policy engine, which will run the security policy rules for this particular traffic, and likewise there are specific components which is part of each and every layer. Like in content ID, you have got data filtering, URL filtering, threat prevention elements. In app ID, you have got application protocol decoding, application signatures, application protocol detection and decryption techniques, heuristics, etc., right? And once the policies are allowing those packets to pass through, then only the traffic will be allowed. That means the processing of a packet in one go or single pass by your Palo Alto Next Gen Firewall, it will enormously reduce the processing overhead, unlike other vendor firewall using a different type of architecture which produces a significantly higher overhead when processing these packets that is traversing the firewall. So it's been observed that the UTM, which processes the traffic using multipass architecture, it results in process overhead, latency reduction, and throughput degradation, right? So this is one of the diagram that is given here. It says the diagram below illustrates the multipass parallel or multipass architecture process which is used by other vendor firewall, clearly showing differences to the Palo Alto network firewall architecture and how the processing overhead is produced. So there are you can see that the traffic flow for multipass architecture resulting in overhead processing. So there are it is not into one layer, so it has been broken down into several sub layers, as you can see, right? That is the reason Palo Alto Next Gen Firewall having the single pass software, it scans the content based on the same stream, right? And it uses a uniform signature and matching pattern to detect and block threats. By adapting this method, this Palo Alto Next Gen Firewall is negating the use of separate scan engines and signature sets, right? As discussed, the parallel processing hardware, there is going to be it is going to have a combination of dedicated data plane and control plane, which produce stunning performance results. By separating the data plane and the control plane, Palo Alto Network is ensuring heavy utilization of either plane will not impact the overall performance of the platform, right? So at the same time, this means there is no dependency on either plane, as each has its own CPU and RAM as shown in the diagram below, right? That means consider the control plane. So it has got it is going to be the responsible plane for management function, which defines configuration, logging, reporting. That means it has got its dedicated CPU, RAM, SSD, and basically its console port or basically its management port is part of this control plane. So means the firewall's management port or the firewall's console port is part of the or managed via the control plane. In case of data plane, it has got its dedicated RAM, dedicated CPU, right? It will look for signature match. It will have separate processor for security processing, separate engine or separate processor for network processing, which will do the respective job as shown here, right? For network processing, let us say flow control, route lookup, ARP or routing, MAC lookup, NAT, QoS, all those things are part of your network processing. And for doing that, there is a separate CPU and a separate RAM will be given to it, right? So this is, as I've told you already. Okay, so I hope it is clear, and please go through this particular documentations as well as the notes that I have given here. So it will be good for whenever you are applying for any sort of interviews, you might get this kind of question regarding the Palo Alto Firewall network architecture, what are the different components we have and how it is different than the other vendors, so you can have some good points discussed. All right, thank you for watching. I'll see you in the next video.